Chief of Air Staff, DG CAPS, DG Army Aviation, uh, former chiefs, uh, very senior officers under a large number of whom I have served, other officers from sister services, from Air Force, DAs of friendly foreign countries, industry reps, students and friends from media. Very good morning to all of you. Let me begin with a very simple but powerful truth that the forging tri-service synergy and integration in US, UAV and counter-UAS is not merely desirable, it is a strategic imperative for us and for the operational freedom of our three services to protect this nation. No single service can fight the next war alone. Only collective leadership, integrated systems, and shared situational awareness can deliver decisive victory in the battles ahead. We stand at a decisive moment in history, in human history also, and in military history. Unmanned aerial systems are no longer just enablers. They are a means of warfare in their own right, already replacing manned aircraft in an increasing variety of roles and already influencing the outcomes of real conflict right now as we speak. We recently marked the first anniversary of Operation Sindoor, which was India's swift, high-intensity, multi-domain military response conducted under the nuclear umbrella, in which speed, strength, and precision shaped a decisive and favorable outcome. In that operation, drones became a weapon of choice for the first time in this Indo-Pak conflict. This has changed the nature of border warfare. The world took note, our adversaries also took note, and so must we also take note, and that is why I think this seminar is very timely. I will speak today on 6 interlinked themes. The changing character of warfare, mass precision, US as force multipliers, man-unmanned teaming, our counter-US response, and what both industry and the defense forces must do urgently. I will close with a look at the larger horizon, because drones are only the opening act of coming robotic war. Let us be clear about what is happening on modern battlefields. The conflict in Ukraine is not simply a war between two nations. It's a living laboratory of hybrid, asymmetric warfare featuring the most rapid technological innovation seen since the Second World War. It is producing lessons that every military in the world must absorb or pay a very high price for ignoring. In 25 alone, Russia launched over 56,000 drone attacks against Ukraine. 96% of the drones not missiles. On 15 separate nights, more than 500 drones flew in a single wave. The nightly drone barrage had become as routine as the sunrise. This is not the future we are talking of. This has already happened. We are transitioning to what experts call data-centric warfare. Data is collected continuously. Sensors, satellite, drones, signals processed by AI and converted into decisions in near real time. The commander who sees faster, understands faster, and acts faster wins. Without credible end-user connectivity and secure data links, this entire edifice collapses. The proliferation of sensors has made the battlefield transparent. Both sides can see each other almost continuously. This has made conventional mass obsolete. You cannot concentrate forces without being targeted. It has forced dispersal. It has made the element of surprise far harder to achieve. Kamikaze drones and FPV loitering munitions have compelled troops to spread out during static engagements. If you look at pictures of Ukraine, Russia-Ukraine war where it is happening, you will not see even a single soldier standing. Electronic warfare, offensive and defensive both, has added another invisible but lethal dimension to each and every operation. The threat is not only at the front. Even in peacetime and subcontinental operations, drones are being used to airdrop weapons, ammunition, narcotics across the international border, to conduct tactical surveillance, and to guide infiltrating militants for terrorist attacks. The drone threat is 24 hours, 365 days a year, not just in war, but right now along our borders and deep inside our territory. For decades, we believed precision and mass were opposites. You could be accurate or you could be overwhelming, but not both. Not without spending a fortune. Drones have ended that trade-off. Today, a nation can launch hundreds of individually guided platforms simultaneously, each costing a fraction of a conventional guided bomb, achieving effects that once required maybe a full strike package of manned aircraft, seed missions, and cruise missiles. This is mass precision, quality and quantity together, and it is the defining concept of modern combat. During Operation Sindoor, Pakistan launched a large number of drones across our western and northern borders in a single operational window. Turkish Songar system, Bayraktar, Chinese IHA, a deliberate combination of surveillance, loitering attack, and swarm assault designed to probe, confuse, and overwhelm our layer defense simultaneously. This asymmetry, cheap attacker, expensive defender, is the central challenge. Our adversaries are also beefing up their own air defense. Pakistan has inducted Chinese air defense systems specifically to counter our drones and low altitude threats. We must continuously develop our tactics and technology to stay ahead of these adaptations. The answer is not to slow down, it is to accelerate our mass precision and also achieve production on demand. A BrahMos missile is only as lethal as the target data which is fed into it. A Rafale aircraft is only as effective as the situational awareness its pilot carries into the fight. This is where US becomes transformative, not as a primary weapon, but as the intelligent, persistent enabler that makes every other weapon system sharper and more decisive. A US loitering over a contested zone like HAPS or MQ-9 can update target coordinates in real time, detect target movement, and conduct immediate battle damage assessment after a strike. Every high-impact missile battery and fighter squadron must now treat persistent US queuing as a standard operational condition, not an exception. Optical fiber-based and tethered drones deserve a special mention here. Unlike RF link platforms, they are not susceptible to jamming, a significant tactical advantage in an environment where the adversary is actively contesting the EM spectrum. Now, next point is related to man-unmanned teaming. It is the idea that crewed and autonomous platforms operate as a single coordinated force. The pilot makes intent-level decisions. The autonomous wingman executes, conducting recce ahead of formation, launching decoys, prosecuting pre-approved targets, or relaying communication when GPS is denied. Picture this operational concept: a two-ship Tejas Mark 1A formation coordinating in real time with Ghatak class autonomous platforms, each carrying a different mission payload, electronic warfare jammers, targeting sensors, or precision munition. The lead pilot commands an integrated strike package through his helmet-mounted display without putting additional crew at risk. This is how India will fight, Indian Air Force will fight tomorrow's air war. The United States is doing this today with the XQ-58A Valkyrie alongside its F-22s. Australia is building the Boeing MQ-28 Ghostbat for exactly this role. India has Ghatak. We must accelerate it with urgency, with a clear operational requirement from the Indian Air Force and with a committed joint program between DRDO, HAL and qualified private sector partners. A formal Indian Loyal Wingman program with a suggested 2032 initial operation clearance target must become a very high priority target. Every technology that enables offensive drones carries a vulnerability for those who cannot defend against them. And here, India has a story of genuine achievement, one tested under fire in Operation Sindoor, and one we must now scale with greater urgency. When Pakistan's drone offensive began in May 25, India activated its Counter-UAS grid. At its heart was ISECA system, which had fused other systems like Akash Tir, hundreds of radars and RF inputs from all three services into a single coherent air picture, enabling real-time engagement sequencing across multiple effectors simultaneously. ISEC is India's answer to the fragmentation problem that has undermined every multi-system air defense network built anywhere in the world. It worked. Now we must build on it. India is now institutionalizing this through Mission Sudarshan Chakra, a permanent joint air defense, joint counter-drone, counter-UAS, counter-missile grid that will integrate the proliferation of various missile systems, UAS systems acquired by all three services over the past 5 years into a dedicated tri-service network linked to our NTNs. This is exactly the right approach. Not three separate grids that cannot talk to each other, but one unified sovereign architecture which also has counter-drone in it. The mission must be resourced and executed at pace. The hard kill systems that defended us in Sindoor deserve recognition. DRDO's D4 system built by their various labs, manufactured by Bell, it used RF jamming, spoofing and directed energy lasers. It needs to be scaled up quickly, and the range of this has also to be increased. From large number of systems also came from private sector at that time. But we must be honest about what lies ahead. Adversaries are already building drones that defeat RF jamming, using fiber optic control, AI-guided autonomous navigation, low observable airframe. So our counter-UAS architecture must evolve continuously. Passive EO, IR detection, acoustic sensors, AI-enabled threat classification, all this should become part of our counter-UAS shield. Now, I want to speak directly to the industry leaders in this room. What India's defense forces need is not the most sophisticated system on paper. It is the most rapidly deliverable, battle-ready, operationally relevant system tested and in our hands. Let me be specific about what that means. We need platforms that thrive across all our operating environments, be it high altitude in the Himalayas, blowing dust in Rajasthan, or on Arabian Sea decks corroded by salt. The drones which is working in laboratory but fails in Siachen is not a defense product, it is a liability. Second, we need battle-proven subsystems, propulsion systems that withstand dust ingestion, high altitude oxygen, EO, IR enabled payloads that deliver in degraded visual environments. Third, we need a digital backbone with genuine teeth, AI-driven autonomy that survives electronic warfare, secure data links with quantum-resistant encryption, edge computing that enables real-time target identification when GPS is denied. Fourth, we need testing and sustainment infra, EMI, EMC laboratories that certify performance in contested electromagnetic spectrum, digital twins for predictive maintenance, and modular upgrade pathways that give these systems 20-year operational life cycles. We cannot keep replacing systems every 5 years because no one built in the ability to upgrade them. Fifth, on the counter-UAS side is scalable detectors from handheld to theater level, laser effectors with precision kill chains, and cyber-hardened command systems that are immune to hacking. And last but not the least, indigenous content. Every critical subsystem must be Indian, not assembled in India with foreign black boxes inside. Genuinely Indian, designed, manufactured and sustained here. Because in a conflict, foreign supply chains will break and Indian ones must not. So today morning I was reading this in Times of India newspaper. There was an article related to a company in Bangalore who is now setting up a export company in Portugal, and they have got a 30 million order from Europe. So this is the way to go. Our exports have increased drastically in the last year thanks to our private sector people, and this is Atmanirbhar Bharat. It is not a slogan, but a factory, not a PowerPoint, but an export order. Industry, this is the standard, match it, exceed it, and build on it. Now, everything I have described so far, SOMS, MMT, Ghatak, Counter-UAS, is one chapter of a much larger story which is unfolding. UAV warfare is not a destination. It is the vanguard of robotic war. Robotic war is the future in which autonomous machines will dominate every battlefield. In the air, on the ground, there will be lead combat robots on land, autonomous underwater vehicles beneath the ocean, and orbital systems in space. Human beings will not disappear. They rise, they will become commanders of autonomous formations, making intent-level decisions at machine speeds with AI as their staff. Three forces are making this real. First is the AI, using computer vision, sensor fusion, autonomous navigation, etc. Second is low-cost manufacturing, additive manufacturing with modular electronics. Third is networked swarm autonomy, algorithms that allow thousands of units to act as one coordinated force, faster than any human decision cycle can match. Russia is testing Leggett combat robots in Ukraine. China's PLA is fielding autonomous underwater gliders in the South China Sea. DARPA is integrating ground robots into infantry formations. These are not experiments. They are deployments and they are accelerating. So now, whatever investment we make in our doctrine today, multi-interface, swarm coordination, AI-enabled counter-UAS, everything, the doctrine we write for Ghatak today, for example, will become the template for India's multi-domain robotic force of tomorrow. We are not just buying drones or counter-UAS or US systems. We are building the intellectual, institutional, and industrial foundation for the next generation of warfare. Now, let me close with 5 clear priorities that must drive us in the years ahead. The first is for me, or the defense forces, we need to operationalize the MQ-9B fleet rapidly. It is on order, and integrate it in a tri-service manner with all its sensor data directly into ISCCs and Akash to take quick decision. We have to make persistent US queuing the standard for every missile battery and fighter squad. The eye must always be open. Second is we have to accelerate Ghatak and establish a formal Indian loyal wingman program, give it a clear operational environment and a committed, let's say 2030 IOC target. Third is we have to scale Mission Sudarshan Chakra very, very rapidly, urgently. Build the permanent shield where laser directed energy weapons are there and all our installations are well secured. We'll have to create a national counter-UAS and US ecosystem through using IDEX, Aditi, TDF, and maybe direct order, fast-track procedure very, very quickly, and each and every service must take part in this. Lastly, we have to build doctrine and human capital at the same pace as hardware. We have to have a joint US and counter-US training center with live simulations, red team exercises, and a doctrine cell that updates tactics every 6 months, not every 6 years. The hardware is only as good as the people who command it. So Operation Sindoor has showed us what India is capable of when speed, technology, and joint resolve come together. Our grid held, our lasers fired, our systems worked, they fused the picture, and our commanders acted decisively. But one successful defense is not a strategy. The adversary is watching, he has watched, he has learned, and is adapting today, and that too rapidly. The drones are already flying, robots are coming. In this room sits the strategic leadership, the industrial capability, and the intellectual firepower to ensure that India does not just respond to this revolution, India leads it. I have full faith that we will. I wish this seminar a great success. Thank you for listening to me. Jai Hind.